So for here on notes 1-7B, so this is like the second part, we're looking at a lot of vocab again. So let's just jump right into being able to identify what a term is. We also want to be able to identify like terms, coefficients, constants, and we got to be able to simplify. So a lot of vocab here. So we're going to start with a term, and it is a number. It could be a variable or a letter. A variable or the product. Product means the answer to a multiplication problem of a number and one or more variables. So let's just think about what some examples could be like for that. So we could just have a plain number, so we'll just write down the number 7 here. We could have just a plain letter. I'm going to put a comma here. We could have just like the letter A or the letter X, letter Y. Those are pretty common letters that we use for variables. Or we could have the combination of numbers and more than one letter. So let's just do like a -2AB. These are all examples of terms. The product, meaning multiplication of numbers and letters, or just the number by itself or the letter by itself. So those are terms. Let's talk about what a constant is. And a constant is a term that has no variable. So think of your numbers. Those are terms, or those are constants. So a constant could be like the number 2 or the number -8. It could be a fraction, 1/4. It could also be a decimal. So constants are just numbers with no letters attached. They are still a term. They're just by themselves without a letter attached to it. The coefficient. Let's jump down to coefficient. Coefficient is a numerical factor of a term. So if we were talking about the coefficient of a term, we're talking about the number of it. So let's look at like 2A. The coefficient is the number value of this, which is 2. 2 is your coefficient. If I had a -7xy, -7 would be your coefficient. It's the numerical factor, the number in front. Let's talk about what we call like terms. Like terms are super important. We have to be able to identify them. And they have the same letter and, keyword, the same power or exponent. So if you have like terms, you have to have the exact same letter and the exact same power. So for example, if I had 3x and 5x, those are like terms. They have the same letter and the same power. The power on these are actually to the first power because it's not written. If I have 2y squared and 5y squared, those are like terms because they both have the letter y, and the y is both to the second power. So we're talking about like terms. We also could have like terms like a -3ab and 2ab. They both have the exact same letter of A and B. And so those are like terms. And like terms are very important because we can simplify them and combine them. So what does it mean to simplify? I look at the very last definition here. To simplify means that you have no parentheses and you have no more like terms. If you have simplified completely, you have no parentheses and no more like terms. So I want to go over an example with you, and I want us to identify all parts here. So let's go ahead and an example. And this would be similar to what you would possibly, I'm going to star it, find on a test question. So if I have 5x minus 3 minus 3x plus 6y plus 4. First of all, if you haven't gotten sick of it yet, you will at some point. I want to change all subtraction to addition because terms are separated by addition symbols. So I'm going to change my minus 3 or subtract 3. I can keep my 5x the same, change this to addition, and my positive 3 becomes a negative 3, the opposite. And the same with the next one. Keep the number in front the same, change to addition, and add that negative symbol. So we really have a 5x plus negative 3 plus negative 3x plus 6y plus 4. And we want to talk about our terms and how many we have. I'm going to underline them. They're separated by the addition symbols. 5x is a term, negative 3 is a term, negative 3x is a term, 6y is a term, and 4 is a term. We technically look at what we underline. We have 5 terms. So our terms, there are 5 of them. A term is a number, a term is a letter, or a term can be the product of a number and a letter. Now let's talk about what our like terms are, and let's circle those. So the first like term that I see is the 5x, I'll box it in. And my other like term would be my negative 3x. They both have the letter x. So my like terms here would be my 5x and my negative 3x. Do you see any other like terms? I do. My negative 3 and my positive 4. They are just constants. They're plain numbers. We can combine them because they're just plain numbers. They're like terms. Let's go ahead and talk about, since I just said it, let's talk about those constants. Our constants have no letters. So my constant here is my negative 3 and my positive 4. These have no letters. And last but not least, we can talk about what our coefficients are. And we know that our coefficients are numbers that are in front of a letter. So one of my coefficients would be the 5. Another coefficient would be my negative 3. But I have a third coefficient, which is the number 6, because it's in front of the y. And last but not least, we know that when we are completely simplified, we have no parentheses, which we don't, but we also are completely simplified when everything is combined that can be combined. So we're going to look at those like terms. We know we can combine our 5x and 3x here. And 5x and 3x is going to be, negative 3x is going to be a positive 2x. We also know we can combine our negative 3 and our positive 4, which we know is a positive 1. And I've taken care of 5x, I've taken care of my negative 3x, I've taken care of my negative 3 and my positive 4. There's nothing that I can combine with my 6y, but I can't just leave it off. It's part of my final simplified expression. And that would be your simplified expression. You've combined all your like terms, and you can't do anything else. No more like terms and no parentheses. That's it. See ya.